For section 3.2, we're going to be talking about another way to divide with polynomials called synthetic division. Now with synthetic division, we have a few things I want to talk about, but the first thing is just recall that if we had like maybe 8 divided by 5, you would tell me the answer is 1 with a remainder of 3, right? 5 goes into 8 one whole time with 3 left over. Another way we could write this is to say that 8 is equal to the quotient times the divisor plus the remainder. This works all the time, so let me write that out. The dividend is equal to the quotient times the divisor plus the remainder. Now today we're going to be learning about something called the Factor Theorem or the Remainder Theorem, but just to get started, it's important that we know that we could always do division and write it out this way. Later on we'll be talking about the quotient just being like a q of x function. The divisor is going to be x minus r, and the remainder, this is like the pretty big deal here, is just f evaluated at r. So you put r into f of x, and you get the remainder. We'll talk about that in a little bit. First, what I wanted to show you is how to divide and determine if the divisor is a factor of f of x. Now factor, let's think about what that means. Like, is 2 a factor of 8? Yeah, it goes in evenly, right? Is 3 a factor of 12? Yeah. Is 3 a factor of 10? No, because there's a remainder. What factor means is factor just means the remainder, when you divide, is equal to 0. So let me show you how this works. First, let's do 5x to the third minus 6x squared minus 28x minus 2, and we'll divide that by x plus 2. First thing I want to do is show you what this looks like using long division, which should be a review for everyone. And next I'll show you how this looks like using synthetic division. And we just want to know, is the remainder 0, yes or no? So let's do long division. We're going to divide x plus 2 into 5x to the third minus 6x squared minus 28x minus 2. We always do long division by looking at the first terms. X times what is 5x to the third? The answer is 5x squared. Then we're going to multiply that times x and then times 2. So we get 5x to the third plus 10x squared. And don't forget, when we do division, we have to remember to subtract at this point. And if we do that, we'll get negative 16x squared minus 28x. Okay, so x times what is negative 16x squared? The answer is negative 16x. And we're going to multiply that just like we did before, times x and times 2. And remember, we are subtracting. Subtracting a negative turns into addition. Subtracting this negative turns into addition. And we get 4x minus 2. So x times what is 4x? 4. So 4 times x is 4x, and then 4 times 2 is 8. Remember, we have to subtract these, and we get a remainder of 10. So the question was, divide and determine if the divisor is a factor. The answer is not a factor. because the remainder is equal to 10, right? The way we could write this is we could say that 5x to the third minus 6x squared minus 28x minus 2 is equal to the quotient times the divisor plus the remainder. And if you FOIL that out, it would work out to the same thing. That's how we do long division. Let's learn a new technique called synthetic division. Now, in order to do synthetic division, we have some requirements. It's a little shorter than long division, but we do have some requirements. First requirement is we have to be dividing by a linear binomial, meaning two terms, the highest power of x is 1. Second condition is we have to, the leading coefficient of the divisor has to be 1. So in this case, our divisor is x plus 2. It is a linear binomial, and the leading coefficient is 1. So the way that we set this up is we draw a box here, summation line here, and what goes inside the box is the actual root. So when you write it as like in parentheses like this, that's called a factor. But if we were to set it equal to 0 and solve, you get x is -2. That's what's actually going to go in our box. Some people just remember it as taking the opposite of what's inside, and that's fine. So if it says +2, write -2. Next, we're going to just get organized and start with the highest power of x, and then drop that down 1 degree each time until you just get x to the nothing or just the constant number. Okay, let's put our coefficients in: 5, -6, -28, and -2, and we'll start. Anytime you go up and down, you're adding. Anytime you go diagonally, you multiply. So watch how this works. Start with the first number, 5. There's nothing to add with the 5, so you could just do 5 plus 0 or just bring our first number down, get 5. Next, we're going to do -2 times 5 and put that number right here, -10. Then we're going up and down, so we're going to add -6 plus 10 is -16. Next, we're going to do -2 times -16. That's 32. That goes right here. Add them up. We're going up and down. That's 4. -2 times 4 is -8. Going up and down, add those together, you get -10. The last number is always your remainder. This is going to be called a depressed polynomial. The reason why it's called depressed is that's a mathematical term to say 1 degree lower than the dividend. So if you look at our original problem, it says 5x to the third. So we're not going to say 5x to the third here. We're going to say 5x to the second. Drop it down 1 degree to get 16x. Drop it down 1 degree just to get the 4. And then we do have the remainder of -10. So you see we get the exact same answer here. I should have wrote the remainder was -10. I'm just seeing that now. We get the exact same answer we get using long division. Synthetic division, once you get the hang of it, it's going to go quite a bit faster. Now, just like any time when you're doing division, if you are missing a power, you have to put 0 there. Otherwise, you're going to get hung up. Let me show you with another example. What if we had 4x to the fifth minus 2x squared plus 1, and we're dividing by x minus 1. Let's just do synthetic division. So what we're going to do is take the opposite. So it says x minus 1. We're going to put +1 in our box. Summation sign. Start with x to the fifth. There's no x to the fourth, but we have to keep going down by 1 degree until we just get nothing. and that's going to be our number. So we have 4x to the 5th, no x to the 4th, no x to the 3rd, negative 2x squared, no x, and then 1. Bring the 4 down. 4 times 1 is 4. Add them together. 4 times 1 is 4. Add them together. 4 times 1 is 4. Add them together. 2 times 1 is 2. Add them together. 2 times 1 is 2. Add them together. You get a remainder of 3. And our depressed polynomial would be 4x to the 4th, because it's 1 degree lower, plus 4x to the 3rd, plus 4x squared, plus 2x plus 2, the remainder of 3. So if we were going to write this in the form that we talked about in the beginning, we have our dividend is equal to our, our quotient, times the divisor, plus the remainder. So this is also not a factor because the remainder isn't 0. The remainder is 3 here. Okay, so let's do something else. Let's try this one. X squared plus 4x minus 5 divided by x plus 5. So let's do the same thing, right? So synthetic division, we're going to put negative 5 in our box. We get, we have an x squared term. Then we have an x, and then our number. So we have 1x squared, 4x, negative 5. 1, negative 5, negative 1, 5. We get a remainder of 0, which means that yes, x plus 5 is a factor. So x plus 5 is a factor also means that x equals negative 5 is a root. We'll talk about this more in an upcoming section. Root is another word for x-intercept, which is another word for 0. But we did get a remainder of 0, and our quotient would just be x minus 1. So we could say that x squared plus 4x minus 5 is equal to x minus 1 times x plus 5. And that's actually how it factors. There's no remainder. That's completely factored out. I want to finish returning to what we mentioned before, something called the Factor Theorem. Or let's actually start with what's called the Remainder Theorem. The Remainder Theorem says that, remember we had f of x is equal to our quotient times the divisor plus the remainder. And what the Remainder Theorem says is the remainder, when you do f of x divided by x minus r, is just equal to f of r. And that's really important. That's going to save us a lot of time. What the Factor Theorem says, it's kind of like a piggyback off of that, that if f of r is equal to 0, then x minus r is a factor of f of x. So it's pretty much saying if the remainder is 0, then it's a factor. You guys already knew that. So let's revisit a problem we did before. I want to show you how this worked. So I'd say this one, part B, that one was like pretty long. So let's answer the same question using the Remainder Theorem. Is x minus 1 a factor of 4x to the 5th minus 2x squared plus 1? Well, we could do long division and see what the remainder is. We could, let me just write that down. We could do long division. We could also do synthetic division. Or we could use what's called the remainder theorem. If I could spell theorem right. Okay. So the remainder theorem would say this would be x minus r. So r is actually the root. Remember we talked about that over here? We said that if we have a factor, you can get the root by making it equal to 0 and solving it. So r is actually what the root is. So if x minus 1 is the factor, what we're looking to see is x minus 1 is equal to 0, telling us that x is equal to 1 is the root. Okay, so let's see what the remainder is. According to the remainder theorem, the remainder, if this is f of x, the remainder would be when f of 1. That would be the remainder. So let's plug in 1 for all the x's. And we get 4 minus 2 plus 1 is 3. That was pretty fast. If you remember, look what we had up here. For the same problem, we still had the remainder of 3. It's the same answer. We don't really need all the other stuff. If we just want to know if it's a factor or not, we could just use the remainder. So to answer this question, the answer is no. X minus 1 is not a factor. Because the remainder is equal to 3. That would actually be the answer here. Just make sure you always answer the question. Let's do one more problem, and that'll be it for this section. What if I ask you to determine if x equals 4 is a 0 of f of x is equal to negative x to the third plus 8x squared plus 63. So I'm asking you, is it a 0, or I could bring this on the other side and say, determine if x minus 4 is a factor. So we need to be able to go back and forth between if something's a 0 or a factor. Well, remember how we did this. We could do this using long division and see what the remainder is. We could do this using synthetic division and see what the remainder is. Or we could do this using the remainder theorem and see what the remainder is. So let's see if we can figure this out. Let's divide x minus 4 into negative x to the third plus 8x squared. There's no x, so we're going to put 0x and then plus 63. So x times negative x squared gives us negative x to the third. That would, if we multiply it back out, we'd get negative x to the third plus 4x squared. But remember, we have to always subtract this. This would be 4x squared plus 0x. Okay, so x times what is 4x squared? The answer is 4x. 4x times x is 4x squared. 4x times negative 4 is negative 16x. And remember, we always subtract. So we get 16x plus 63. X times 16 is, let's see, 16 times x is 16x. But 16 times 4 is actually 64. So if we go to subtract these, we definitely don't get a remainder of 0. We'd get a remainder of, I think this is 112. So the answer is no. X equals 4 is not a 0, which means x minus 4 is not a factor. Let's try synthetic division. We'll put the 0, or the x-intercept, in the box, or the opposite of negative 4, and we'll divide. We have an x to the third, so we need an x squared, we need an x, and we need our number. We have negative 1x to the third, 8x squared, no x, and 63. Bring the negative 1 down. This would be negative 4, so this is 4, 16, 16, 64. Look at how much faster this is. This is our remainder, right? That's all we need. We don't need a depressed polynomial. So we also see, no, it's not a 0. The remainder theorem is even faster. The remainder would just be what we get when we plug in 4 for all the x's. And if you just type that into your calculator, you get 112. All three of these techniques tell you that no, x equals 4 is not a 0, and x minus 4 is not a factor.